Hello everyone, good morning all. It's a new day today as part of this new session and new batch. Let's wait for another 2 to 3 minutes, others to join. Once again, good morning all. It's 7:03. Let's start the session. Thanks for showing your interest to watch the demo class about mastery in Spring Boot and microservices. So before that, I want to give you a small introduction about myself so that we will be understand each other. So my name is Mohammed Yasir. I have a 17 plus year of experience in banking and BFSA domain. I love solving the problems for the banks and their customers, especially designing the strong and flexible systems using Spring Boot and microservices. I do have a strong cloud knowledge. I have deployed so many applications in AWS and Azure cloud providers. My industrial experience will definitely help you to understand the systems better about Spring Boot and microservices. Also, I will be providing you the what is the real-time problems right now the industry is facing, how we can do the betterment, and what are the problems I was faced and how I have overcome it by providing the solution. So those knowledge I will be sharing along with the session. This will help you to enrich your foundation and also problem solving skills. I'm keen looking forward to travel along with you in this entire course. That's about my self introduction. Without wasting the time, let's move on to the topic of the day, which is nothing but the software architecture. So what is software architecture? Right? This is the agenda of this day. So I'm just covering the what are all the types of software architecture is there. Before commencing it, actually, I want to set the clear context for this particular area. This entire course will be like 70% will be the hands-on and 30% will be the theoretical actually. Today is day one. You people will be definitely new to the technical jargons. So I need to give you the set the context, right? So you only then you people will be comfortable with the technical jargons, what we are going to use in the session or the course. So today's class will be like more than the technical concepts. Because I want to introduce you what is software architecture, what are the types are available in the industry, and their concerns and flaws, and how we are going to build the system, and what is the difference between the Spring and Spring Boot. how to choose the technology to building the microservices. The first two sessions will be more theoretical because I want to introduce you the technical jargons, and you have to comfortable with the technical words. Only then you can able to understand the system better. Once you are comfortable, we have a lot of hands-ons in place where you can able to get a lot of confidence to build the scalable systems by using Spring Boot and microservices. So I'm just repeating again. It is like 70% hands-on and 30% of theoretical. Not only that, I have a intermediate quizzes in place, and we have a technical question and answer session at the end of the session. And also, what is the industry was facing the problem particular topic, all the things will be being discussed then and there. It will be giving a lot of confidence, not only a technical, also with hands-on and the current trend in the industry, what's going on, how we can improvise the design. Those are the things we will be discussing. The topic I have listed down, that's an agenda that you can see in this slide. So what is software architecture? Types of architectures. That's going to see it in the furthermore slides. So I always start the day or a session with a motivational quote actually. Believe you can, and you are halfway there. That's a Roosevelt's excellent motivational quote. We always get motivated to make the things done. Right? Yep. So I have some set of things should be followed in this entire course. Only then the things will be fruitful. This is the pattern I'm going to follow in this course. The first 5 to 7 minutes always will be the recap of the last session so that you can able to quickly refresh the concepts along with me. And the new session will be start 7:10 a.m. IST. If you have a doubt in ongoing topic, please raise the hand or just text in the chat box so that we can discuss then and there and make it clear. Sometimes you will be excited. The question will be out of the context of the syllabus. In this kind of topics will be discussed at doubt clarification time. That is nothing but last 5 to 10 minutes. You can block it where we will be discussing. 1 minute, I got a ping here. What is Spring Boot? Yeah. Andrew, I'm going to explain in detail. Don't worry, I have slides also in place. I'm going to explain. This will be a 2-hour session where I'm going to teach you all the set. So you have to start from the scratch. Only then you can understand what is Spring Boot. That's why I'm slowing down the pace. Let's understand the software architecture first. Then let's move on. Why Spring Boot is required? Ultimately, to answering you directly, Spring Boot is required to build the scalable microservices architecture. That is a straight to the answer. Okay. To understand what is microservices, you should know. That is why I have put the topics in these slides from the bottom. Be patient. Just follow me. You will be getting all the things in this session. Thank you, Andrew. You're welcome, Andrew. Yeah. Okay. Before I start this architecture, please allow me to share the general information about this particular course. Look at here. It's a general information from the Logic Labs Technologies. The first two sessions will be free to attend. From third session onwards, the Zoom link will be shared to only registered participants only. The day one session recording will be uploaded into the Logic Lab Technologies YouTube channel, and the link will be shared in the WhatsApp community. The day two recording session will be shared only to the paid participants only. There is some restriction, no batch shifting and no amount refund. It's a general information for you people. For any of the session updates, you just to follow the Logic Lab Technologies WhatsApp community and follow the announcement options for the session updates. All the notes session recording will be available in the LMS portal that is called Graphy. All the notes, what are the PPTs or whatever the diagrams I'm going to show you in the, all the things will be uploaded into the Graphy after the session. You can go through and revise it, make the things done. The Logic Labs support team will be available from Monday to Saturday in between 9 a.m. to 7 p.m. IST. If you have any clarification should be done, please drop a mail to support@logiclabtech.com. Not only that, they are providing the voice support as well. This is two numbers displayed here. You can able to go with it. Okay, let's come back to the topic. Just a general information I would like to give it. Let's jump into the topic of the day. So what is software architecture? That we need to understand. Only then we can able to understand from the scratch and able to build the effective systems once you are comfortable with the technologies. It's a fundamental structure of a software system. If you are planning to build any of the mobile app for the e-commerce system tomorrow, or any of the hotel management like a Zomato or Uber kind of travel things, as if you want to build, right, you should not, you should, you must understand the fundamental structure, how the things are working internally, how, what are the discipline we have to follow to create a strong and scalable system. So it is a high level decision making. For example, if I want to build a house, right, we are not straight away going to the plot and not building the things, right? What we are doing, we are going with the diagram. We are going to the engineer is drawing the designs and sharing to us. We are reviewing that and we are customizing it. And finally, multiple reviews After that, the design will be frozen. The similar way, when you are designing your software, you need to understand about the software design. How you are related to the house making, right? House building. How many bedrooms your house should have? How many restrooms should have? How many kitchens should we have? So all the things will be clearly planned in the layout. Similarly, when you are building the software systems, you should have mentioned all the components, how the components will be interact each other. Everything should be mentioned clearly in this software design. Only then we can able to come up with the high level design decisions, and also can able to build the scalable application very easily. Okay, that's the power of the software architecture. Okay, so later you will not be get any of the issue with the design. So how the components or modules are intercommunicated to design the desired functionality and performance. So everything should be clearly done in the design phase of the software life cycle. Only then we can able to build the scalable systems error free. That's about the software architecture. So you should have a strong fundamentals. That's very much important. That will be the key for building the software system, effective software systems. We have a lot of software architect already available in the market. As you see in the slide, we have 4 to 5 software architecture is there. The first one, monolithic. You people already may be comfortable. What is monolithic architecture? Monolithic architecture is nothing but very simple. You are building a system as a single source. Okay. For example, I am going to build one of the software, which is nothing but the employee management. In the employee management, I have a lot of sub modules, right? I have a login module. I have a leave management module. I have a payroll module. I have a task module. All the source code will be bundled together as a single unit or a single application, or in technical words, it's a single war file. So you have a tight dependency between the modules. Whatever I said, login model, registration model, task model, or leave management model, or payroll model. Okay, all the modules within the source code will be tightly coupled and tightly interdependent each other in a single source code unit. That is called monolithic architecture. Don't worry, I have a lot of slides in place where I'm going to explain detail. Okay, just covering up now. So then we are going to talk about the service-oriented architecture. What is that service-oriented architecture? It is a upgrade or fine-tuning of the monolithic architecture. So here, what are the services we identify? For example, I told you login module, registration module, payroll module. Okay, all the modules are called service here. Okay, all the service will be segregated, and all the three modules will be communicated via ESB, Enterprise Service Bus. That is called service oriented architecture. So here We are fine tuning the monolithic architecture in the better way or scalable way. Okay, so in monolithic architecture, we have a tight dependency between the all the modules, and it is a single unit of the source. We are just improvising it better in terms of service oriented architecture. In that, whatever the module I said, right, I'm just taking out, separate out from the single source of unit as a service, registration service, login service, and payroll service. These services will be the independent component, but the intercommunication between these three services are via enterprise service bus. I have a diagram in the subsequent slides. I'm just giving a overview about it. Okay. And then we do have a event driven architecture where the communication will be happen between the services via MQ or Kafka or any of the message broking systems. That is called event driven architecture. Maybe I have a good example in place where I'm going to explain the detail real time problem, and then I'll relate it. Then at last we have a microservices architecture. That is one of the type of software architecture where the components, whatever things we are telling, right, it's loosely coupled the system. When the system will be, or dependent systems are loosely coupled, you have an advantage of scalability problems and the impact of the services are less. For example, I have a login services model. I have a registration model services. If something went problem in my login model, example, you say some wrong code has been deployed into the server in the login model. Okay, what will happen? My registration model, it will not affect because there is loosely coupled. These models are loosely coupled and deployed into the server. So one of the dependent component is down. It will not impact your subsequent model because it is loosely coupled. Every microservices serving their own purpose to the customers, right? As like login model, how it is useful for the login. The same way, the order management or any of the product management will be serving the purpose of its own purpose to the customer. So it is loosely coupled. Any of the service gone down, it will not impact the other subsequent models in microservices architecture. But in case of monolithic architecture, if someone deployed the wrong source code into the server, the application will go down. All the models will go down. It will be impacting the customers very much, huge impact business, right? That's about the common type of software activity. We are going to cover up things in detail in the subsequent slides. Okay, so I'm talking about the monolithic. Any pings now? Any doubts, clarifications? Please ping me in the chat box. We will be clarify the doubts then and there and move on to the next topic. So I just want to make you sure that all the things what we have discussed, everything should be understand 100% when you're going out of the session. That's my clear set agenda. Let's continue the topics. Okay, so today I'm going to explain the monolithic architecture. As I told you, I done a overview already. So monolithic architecture is a traditional software development approach where the entire application is built as a single unit or single application. I give an example, right? Employee management. Okay, even though I have a multiple sub models within the employee management application, my all the source code will be committed in a single unit only. Okay, for example, I have given the second point, all the components, user interface, business logic, data access, all are tightly coupled and deployed together. You can't deploy your business logic alone or your user registration service alone into any of the server. You have to deploy all your source code as a war file and deploy into any of the application server, right? You have WebLogic server or any of the Windows server or Tomcat server, any of the deployment server. If you want to deploy your application as a single unit only, you can able to deploy. For example, traditional desktop application, even in the real time also, there are a lot of monolithic applications in the banking domain it's running, because banking domain have a lot of sensitive business logics are there. People are fearing to move that logic from the monolithic architecture into microservices architecture, because it's not a technical limitation. Here, the problem is the business logic. The business logic which is running in the monolithic architecture should not missed out when you are moving into the microservices architecture. Otherwise, the huge business loss for the banks. Okay, so there are so many banks or so many e-commerce applications are still doing the monolithic architecture in place in the production. For example, today, if you want to start up any of your company, what is the very good option is that you start your idea, business idea, and develop the application in monolithic only. That is very easy. Why I am telling? I'll tell you in the subsequent slides. Okay. You just keep in remember that anything, if you want to start from the scratch, whether it is mobile app or any other web application based application, anything if you want to scratch, always start with the monolithic architecture. Okay. Once the system is comfortable and it is running very good, satisfying the customer's needs, then think about moving from the monolithic to microservices architecture. That is a good way of designing or planning the systems. Okay, coming back to the topic again. Okay, so pros, what is a pros here actually? The simplicity. The entire application built as a single unit. So deployment is very easy, right? You can check out the code. You can ask your developers to start the code. Very good. Why? That's why I have put the word, always start your application code by monolithic way of architecture. Okay. That is easy for development, easy for the deployment, because it's a single unit, right? Single var. You can directly go and get the var, put it into your application server. That's it. So your application is startup is completed. But in terms of microservice architecture, each and every modules or microservices are independent entities, loosely coupled. As I told you, it's a loosely coupled. So each and everything as a jar file, each and every microservices as a jar file. You have to deploy how many ever modules or how many ever microservices are there. That many deployment you have to do. That's a limitation of the microservices architecture. In terms of monolithic architecture, it's a single unit. It's a single war file. You can directly get it deployed into your application server. That is easy for development and deployment. Okay. And what is concern? Flexibility, right? So flexibility is one of the concern, and agility and scalability and technical stack limitation and fault isolation. As I told you, if any of the module, that is login module, some wrong code has been committed and deployed into the web application server, the entire application will be gone down. That is a problem with the fault isolation. What is the technology stack limitation? Once you choose the technical stack, for example, I am going to develop my application in Java, you have to strongly stick with the single technology stack only. You can't switch from the Java to .NET later. That's not possible. Okay, that's one of the main technology stack limitation. But in terms of microservices world, You can free to choose the technology because, for example, my login module, I have built the system with help of Java. I have a leave management service where I have developed the microservices by using .NET. I have a payroll microservices by using the Python. Everything is possible in the microservices world architecture. But in terms of monolithic architecture, that flexibility is not there. We have a strong technology stack limitation in the monolithic architecture. Okay. And scalability is another problem. Why it is a problem? It will be always support the vertical scaling. Okay. What is vertical scaling? Vertical scaling is nothing but when you are deploying the war file into any of the application server, it will be occupying the more memory and CPU cycle of the server. Whenever you are getting more server load or request into the server, the memory will be being occupied, right? So, for example, if you go to Amazon Big Day, right, Big Day sale or something like that, you will be getting more user loads, right, for the ordering to the application. By the time, if you would have a monolithic way of architecture code, then you need additional servers in place to deploy the war files. So monolithic, it will be occupying more memory in terms of vertical scaling. So you have to procure more and more servers which have the high capacity of memory, high capacity of CPU performance. Only then you can able to survey the load. That's a problem about the scalability issue. But when terms of microservices architecture world, you don't have such a problem because you are broken down your entire application as a single unit, right? Or loosely coupled into units. That units you can able to easily deploy into your application servers. So deploying the war is something different. Deploying a small microservice is different because it's a loosely coupled isolated service. The size will be very much small compared to the war size. That's why the scalability is easy and maintained. That's about the pros and concern of the monolithic architecture. Let's move on to the next slide. That is nothing but service-oriented architecture. It is a granular upgrade from the monolithic to the service-oriented architecture. Okay. For example, e-commerce application. Okay. So what we are doing in the service-oriented architecture, I will tell you. Okay. So what I'm going to do, I have a single unit of code in the monolithic architecture, right? That one, I'm going to identify what is the major module in my monolithic architecture code. For example, I told you login module, registration module, or any of the payroll module if you take. Okay, payroll. These three I'm identifying and then taking that as a service. Okay, taking that as a service and then I am going to communicate over it by a network by using the enterprise service bus, right? That's the intermediate layer. I have a diagram also in later. Maybe I'll show you just to get the things now. Concepts very strong. Then you can connect it in the next slides. Okay. So service oriented architecture is nothing but the modular, reusable and loosely coupled from the generation of monolithic architecture to the service oriented architecture. Okay. So I am identifying the major services out of my monolithic to service oriented architecture. So I identify my user service, registration service, and payroll service. This all the three will be exposed as a service and then communication with each other by network. How it is being communicated? It is by using the electronic service bus. So here also process concern is there. Okay. For example, process flexibility, scalability. Whatever the monolithic is facing, The same problem is coming into picture also, the concerns perspective. So performance overhead, because whenever you are going with the communication over the network, there are a lot of chances of network drop, right? The token drop happen in the over the network protocols. That's the performance overhead. Every architecture has their own pros and cons. Okay. So we have to handle it separately. Only then we can achieve our desired goal. Okay. So pros perspective, it's very much flexible, scalable, because you already broken down the dependent systems separately as a service, right? So your flexibility is coming into picture, scalability also coming into picture, and maintenance will be easy, and interoperability. You can communicate via JSON or XML. Everything will be easy for you. Okay, for the service oriented architecture. What is concern? The performance overhead. As I told you, it's a network protocol drop may happen, which will lead to the communication gap. Again, coming to the cost level, the initial setup and infra cost will be more and more to establishing that particular infra, because you have to include the service registry, you have to include the message brokers, whether Kafka or other things as our governance framework. So everything you have to accomplish or set up the base setup, only then you can be able to go for the service oriented architecture, which is cost oriented. That's the cons. Let me move on to the third one. Any pings? Any ping? Any doubts so far? Please ping me in the chat box so that we can connect and then get the things clarified. Okay, fine. Thank you. Let's move on to the third one, microservices architecture. Okay, so what is that? As I told you, the single unit of my source code will be broken down as a module based. For example, login as a separate microservices. My registration is a separate microservices. My employee payroll as a separate microservices. Here, all the things are loosely coupled. Okay. And then each service is responsible for their own specific business problem only. Okay. What login module does? It will be validate the user authentication and allow to the application. That's the scope of the login model, login microservices. And for example, order microservice, if we take, it is responsible to get the order, update the inventory, and then send back the things. Okay, like that, each and every microservices has their own business problem solving. Okay, and can be developed, deployed, and scaled independently. That's very, very important. This line is very, very important, guys, actually. Okay, so I'm just marking the word. Okay, so it can be developed, deployed, and scaled independently, because tomorrow, if I want to add more server instance on the order microservices, that can be done. For example, I told you in Amazon Big Day Sale, you will be getting more and more order requests to the application, right? By the time I can able to scale up only this order microservices independently. I can run 5 to 10 server instance all together. But login is, I can able to make 3 instance for this particular model. But order service, I'll be getting more and more order, so that I can able to scale up my order microservices into 5 to 10 servers deployment also on the fly. Okay. And coming back to the notification, maybe once after you added the order, you will be getting notified, right? That service you can able to scale up at least 2. That's enough. That is the word I'm marking here. It can be scaled independently based on the load what you are receiving in the application front. Okay. The communication between the each and microservices are typically through lightweight protocols. That is called HTTP or REST or messaging systems. That's why we have a second session about the REST web services, where I'm going to explain in detail. So each and every microservices will be talk each other via HTTP protocols or messaging systems like Kafka or Solace. Okay, so like that, message broker systems are there. through which we will be communicating with each other. Okay. When you are connecting with HTTP or REST, right? It is a synchronous way of communication. What is synchronous? You're expecting or waiting for the response to arrive after the request placement. That is called synchronous way of communication. What is async? You will be posting the request into the message Kafka system, and then you will be doing your work. You're not waiting for the response messages. You will be doing your own work after you're placing the request in the message broker. That is called asynchronous systems. That system can be accomplished by the messaging system like Kafka or Solace. Okay, right now in the markets. Okay. And then this architecture promotes the flexibility, scalability, and the ability to adapt the different technologies for the different service. As I told you, you can be able to choose the technical stacks knowledge based on the technical expert in the team. For example, if you have a very good, strong developer who is a well expert in the Python, then you can manager can go for the system design analysis. If it is the particular model is comfortable with the Python, then he can ask the Python developer to start with the particular microservices. You don't want to wait for the Java developer to join the team and build the system. It's not really needed because microservices architecture is giving the such a flexibility to choose the different technology for the different services. That's the power of the microservices architecture, right? And also it is flexible, scalable, as I told you, based on the load, what your system or application is receiving. Based on that, you can able to scale up that particular entity or scale up or that particular microservices based on the load. That's the example I have given. When the order requests are more and more, you can able to scale up that particular microservices based on the load. You don't need to scale login model. You can only scale the order services model. Only then you can able to handle the load. Okay. That kind of flexibility will be provided by the microservices architecture. Okay. So let's move on to the next slides. This is the diagram. I'm just connecting the dots now. Okay. As I told you in the conceptual level, I'm going to visualize it. Okay. So just take it up this one, actually monolithic world. In the monolithic world, as I told you, it's all the source code, services, modules, everything will be clubbed together as a strong base code base, strong single unit, right? That is called monolithic. When it comes to service-oriented architecture, I am identifying the what are the modules are there in my single source code. For example, user service, I have a registration service, I have a payment service, I have a payroll service. All the things will be identified and make it as a services, independent services. This services communication will be happen via what it is ESB, Enterprise Service Bus, through which the communication will be happen between the two services via network. Enterprise service is the bus which will be communicating or transporting the request from one service to other service, right? That is called service oriented architecture. That you can visualize here. Okay. So whenever the UI, the mobile app, which is receiving the request from the user, which will be routing the request into enterprise service bus, and then based on the request, whether it is a login request or whether it is an order request, based on the type of the request, the respective service will be routed. Okay. So all the communications are happen between the microservices, services by using the ESB in the service oriented architecture. Okay. When it comes to fine grained microservices, all the sub modules are identified and all the sub modules are developed as a microservice. So it is very much loosely coupled. Comparatively, monolithic and service-oriented architecture, all the modules are fine-grained so that each are loosely coupled, can able to scale the system based on the load, right? So look at here, this one diagram. So whenever the user, the UI is receiving the request from the user based on the availability, right? It will be routing the request to the respective microservices. For example, if it is a login microservices, it will be routing the request to login microservices. If it is a order microservice, it will be routing to the order microservices. If it is a notification related, it will be routing to the different. So each and every microservices will be loosely coupled and has their own DB. That's very important part. Every microservices has their own DB so that we are meeting the ACID property. What is ACID property? That's a different story. The ACID property is the one which is the base for the maintaining the database consistency, right? We have here some set of ACID properties should be accomplished to maintaining the data integrity, right? So we should not allow the customer to read the data wrongly. That's the part of the ACID property of the DB. Okay, so all the things will be accomplished in the microservices world. Okay, so that's about this slide. And let's come to any doubts so far. Please raise your hand, or you can just chat ping in the chat box so that I will happy to help you to rectify the doubts. Hope you guys are with me till this slide. If say okay, type okay in the chat box so that I can continue the microservices. We have more and more interesting topics. Thank you, Nadeem, for the reply. Thank you, Nadeem. Thanks for that. Okay. So now coming back to the very interesting topic, that is microservices. Now we understand what are the types of microservices, sorry, architecture styles are there in the industry that we have explored much. So now we are going to focus about the one area now. Okay. So that is called microservices. Okay. So what is microservices? That we have to understand. Okay. That's what I have put it here. It's the communication between the microservices via REST. REST is kind of protocol where you will be communicating from the one microservices to other microservices. The small, well-chosen deployment unit is called microservices, right? As I told you, each and every submodules will be identified and that will be scale up as a single well-chosen deployment units. In the microservices, it is a cloud enabled. So tomorrow, if I want to deploy my application into any of the cloud provider, I can approach the AWS or Azure people and I can able to bring up my application in the cloud in a minute. On the fly, I can able to deploy into any of the service provider. That much kind of flexibility is done by the microservices. That's the power of the microservices. As I told you, the scenario scalability. So whenever you feel one of the module or one of the microservices should be go higher based on the load what we are requesting, right? That can be achieved. That is by a scalability, right? And then I was talking about the flexibility without affecting the entire application from other microservices. For example, I told you the login module, which was going down, which will not affect my and other service. That's kind of flexibility is there. We can able to make it up. And then I'm talking about resilience and fault tolerance, fault isolation, sorry. So what is resilience? Actually, for example, I have a tight dependency with one microservice to other microservices. Okay. The particular microservice is gone down. It can be any of the scenario like network drop or the microservice wrong code has been deployed. There are so many scenarios, right? That particular dependent microservice is gone down. Then we have a provision to handle that particular cases. That is called fallback method by using the resilience 4J framework. For example, very realistic example. Okay. So I'm logging into the any of the banking application. Okay. I have done a payment. Okay. Now I want to look into the payment history or transfer history. The service, the microservice, which is providing the service to give the transfer history, that microservice is gone down now. As a consumer microservices, it is giving a request to the microservice which is providing the transaction history statement. That service is gone down. Now, the consumer microservices will not necessary to show the error to the customer. Instead of that, they can have a intermediate data which is from the database. Is their own database. That database data we can able to fetch it and give it to the user. That is called resilience 4J's methodology of callback approach. We can say it as a callback approach. I'm just drawing it. Maybe I have a diagram. 1 second. Let me quickly check. Is there any diagram about it? Sorry about it. I don't have a diagram. It's a very good use case actually. For example, as I told you, if we want to fetch the transaction history about the last 1 month of data, if you want, 1 minute, I got a ping. Give me a second. Please explain this. Nadim, may I know what topic you want to repeat? Can you please explain in the chat so that I can happy to help you? Okay, fallback. Okay, yeah, I'm going to explain again because that concept is little tweak. For example, Nadim, you are one of the bank customer. Okay, you are logging into the custom banking portal and you done a transaction with your friend. Okay, for example, 1,000 USD dollar, you have done a transaction. Okay, now if you want to interested, you can go to the transaction history and you want to pull the last 1 month of transaction what you have done with the bank. Very simple use case. You understand the use case now? You ultimately you want to see the transaction history which is done by you for the last 1 month. That's the problem statement. Okay. Now, in the microservices world, we have a separate microservices are there, right? Each has their own business problem solver. Okay, login has the problem solver for login methodology. Okay, like that payment, transfers, okay, notification, everything their own microservices serving the purpose. Okay, now as you land on to the transaction history microservices, which is brought down due to so and so reason, might be code deployment by the developer. Okay, during the time, the microservice which is making the transaction history microservice which is gone down, that time you are not really required to throw the error to the customer. Says that the respective microservice is gone down. Says that 400 or 503 service unavailable. You don't really throw that error. Instead of that, you can go for the fallback approach, which is nothing but the alternative to the real-time call. Okay, which is nothing but you do have intermediate data, which is nothing but the last 20 days of data. Your problem statement is fetching the last 30 days of the transaction history from the database. Okay, but due to the service brought down, you will be connecting to your own database, that is fallback method, to fetch last 20 day of transaction and show it to the customer. Though it is 100% realistic data, but you can able to meet the 95% of the customer's problem, right? You are solving the 95% of the customer's problem to displaying the last 25 days of transaction history to the customer. Hope you understand what is the fallback. The expected microservice is gone down. Due to that, it's not really to show the 503 service unavailability issue to the customer because it will be giving the bad experience to the customer. He may chances of leaving the bank. Each and every customer is the money, right? We should not lose any of the transaction, single penny, and we should not lose the one customer, right? That's the ultimate goal. Okay, during the time, if one of the microservices is down, if you throw the error to the 503 server unavailable to the customer, it will be giving the bad experience to the customer. That's why we are identifying this fallback approach where 95% of the realistic data, if you give, the customer will be happy instead of throwing the error, right? That is called fallback methodology, which is done by the resilience 4J framework in the microservices Spring Boot world. Okay. I have a hands on everything in place. Don't worry. You consume the technical jargon now. That's the agenda of the day. Okay. Consume it as much as if you have any doubts, please ping me. I'm happy to help you. I got a ping 1 second, guys. Okay. Thank you. You got it. Very good. Very good. Very good. Okay, as I told you, it's easy to deploy, right? It's easily loosely coupled so that you can go and take the jar out of it and put it into the application server. That's it, done. It's very quick comparatively var deployment. Understand, right? For example, your var size is 4 MB, your jar size will be little than, very little than that, right? So easy deployment and scalability more and cloud enabled. Lot of advantages are there. We do have some limitation in the microservice. I agree. We do have a limitation of the microservices. Yes, agree. But we have a lot of other alternative approach to handle such a problems. As I told you, the fallback approach. We have a network problem. Yes, I agree. But I have a place, the alternative solution that is called fallback approach. Similarly, whatever the problems, limitation microservices has, every problem has their own fallback approach or handling it better than what? Right? That's the power of the microservice. Okay. So why microservice? We have strong in the things right now. Any doubts, please ping me in the chat box. I'm happy to help you. Let's move on to the next slide. That is challenges of microservices. As I told you, we have everything has their own limitations. I agree. As I told you, the complexity of the distributed systems, because whenever you're breaking down the single unit into multiple smaller units, the smaller units should communicate each other, right? Only then the desired things will be done. Desired problem will be accomplished. For example, fund transfer. If you want to do fund transfer between your friends, you want to send money to your friend, you can't directly go and send it, right? It's not possible at all, right? You have to log in, your server credential will be authorized. Then you have to navigate to the payment menu. You have to choose the account. You have to do the step up. For example, step up meaning you have to enter the OTP, right? Whatever the OTP you deliver to the mobile, that you have to key in. And that OTP should be validated. Only then you can allow to send the money to your friend, and following by notification will be sent out to your register mobile number or register email ID, right? This particular transaction itself, we have so many microservices or steps are involved, right? Each and every steps are involving the each and every microservices, right? So that's why you have broken down all the single unit into a microservices. Okay, all the microservices now time to connect, right? So the complexity will be more and more to communicate in the distributed systems, right? My login model will communicate into the my transfer model. My transfer model will communicate to the my 2FA authentication model to get the OTP, and it should validate and then route back the request into the my transfer payment model again back. Then I have to do the fund transfer to the third party. Once it is completed, I have to notify the my notification microservice. Though this many microservices are being involved in this single use case, that is nothing but the fund transfer. I got a ping 1 second. Give me. How do we monitor the health of the? Yes, we do have a monitoring system that is called actuator. Okay, so we have a actuator should be enabled. That will be helping you to providing the dashboard about API, what is the strength of it, what is the health checks. Okay, all the things will be monitored clearly by using the or enabling the actuator in the Spring Boot world. Okay, don't worry, I have a separate hands-on about the actuator in place. Don't worry, Nadeem. Okay, thank you. And yeah, as I told you, the complexity about the distributed system, right? So each use case, I have to go through multiple communication between the each and every microservices. Okay, so definitely it will be giving the problem for the network communication and data management, because each and every microservices have their own DB, right? So the consistency or data integrity will be a challenging part. That's a challenge. Don't worry, I have a challenges. I agree, but I have a good resolution on hand in microservices world. How to overcome these challenges? I have a solution already in hand. Don't worry. But you have to understand the limitation or challenges of the microservices. Okay. Only then you can build the scalable system better in tomorrow. Okay. That's the main core agenda of that. Okay. And then coming back to the topic, that is third point, service dependency and communication. That's a very clear statement. I don't want to explain again. So initial setup and infra cost, because you people already know, right? We have identified the loosely coupled microservices. Everything should be deployed as a independent component into the different web servers, right? Tomcat, for example, Tomcat. Okay, my login model should be deployed into the Tomcat web server. My registration model will be deployed as an independent component into the application server, right? So like that, how many microservices I have in my application, all should be deployed into the Tomcat web server. Okay, I'm example Tomcat. I'm telling we have a lot of web servers in hand. Actually, our application servers, that service we have to deploy it. Okay, so the infra cost will be more. You understand, right? Why it is more? I have so many microservices to be deployed up and running. Only then I can solve the problem statement. Okay, so the infra cost and initial setup will be more. Okay, you have to understand the limitation or challenge. Okay, and then security and access control, because security is the very much key important role in the microservices, because you can't allow your microservices should be directly access it. You have to wrap that by using the Spring security. Only authorized person only can access the your backend services. Why it is so? Because in this real-time world, we have so many bots are born, right? Voice bot, right? Voice bot, transfer bot also we are found out actually. What happened in the last month, we were facing one of the biggest problem where sudden our application server got down actually. Okay, so we identified what is the problem with the particular problem, right? We have taken out the logs from the application server and we identified what is the request, what we have received, what are the transactions are happened, why sudden the application gone down. When we are backtracking the problems, right, we identified that there is a message request is keep on coming from the single IP. Okay, in the single IP address of the particular location, it is keep on sending the same payload, request payload to the application server. Okay, what happened? Every server has their own limitation. Okay, so for example, the 10,000 requests can able to process in that particular seconds. Okay, or you take in minutes. Okay, 1 minute your server can able to capable of processing the 1,000 requests. Okay, during the time you can able to process it. Okay, suddenly 2,000 requests are coming into picture within the time of short span of time. Your server will be memory will be utilized huge. It will not sustain the load and it will be brought down actually. This can be happen. Okay, we can avoid it, but unfortunately we were not able to enable that option in that particular service. Okay, what happened? The particular bot was keep on pushing the same payload again and again, which will be causing the application server memory very huge. So it was not able to handle that load, then it gone down, which will be impacting the business hours or the transaction. Around 3 to 4 hours of downtime we faced. During that time, the customer was facing the problem to transfer the money, and we got so many complaints in the backend customer services, or this and that problems were happened. So you are always very much cautious about enabling the security or alternative approach to protect your backend services. Okay, that's the power of the security, Spring security and access control. Okay, so you have to always wrap up your sensitive application code by using the security layer. Only then you can able to skip this kind of unwanted security issues or production issues. Okay, that's one of the use case I would like to share. Yeah, let's move on to the topic again. Okay, so what is Spring Boot and why it is needed? Okay, as I told you, what is microservices? Everything is completed. Now to build the microservices, there are a lot of frameworks in the market. Okay, so now as part of this course, we are choosing the Java ecosystem. That is nothing but the Spring Boot as one of the popular framework in the Java ecosystem. Because basically we are from the Java background. So I was choosing this Spring Boot is one of the main popular framework to build the scalable microservice. One second, I got a ping from to what are the other frameworks? Yeah, we have a lot of frameworks in the .NET also. Like I'm not able to recollect right at this moment, but we have chosen the Spring Boot as one of the things. Adim, to answering your question. But we have a lot of things in the .NET framework also. We have a tool to develop this microservices. Okay, so now coming back to the topic. Okay, there are several keys need to be challenges in the modern application for the development. Okay, the simplified setup. Why we are choosing the Spring Boot? It has a lot of advantages. What is the advantages? We can easily configure the things very less, and then we can be able to start the development very quickly. I'm just reading out the line, simplified setup. Okay, I'm just underlining it. It has given the simplified setup. You have to tweak or add the little dependency in the pom.xml, then everything will be placed. Because Spring Boot giving the lot of flexibility, lot of feature to the developer and make the life of the developers easy. So developer can able to easily focus about the problem statement was the business is facing and go for the coding. He don't want to bother about the application server bringing up and deploying the things. As deploying the things is also we have a lot of configuration changes. We don't want to put that situation. So we want to make the developer comfortable with the coding about the problem solution for the customer. Rest of the difficulties are taken care by the Spring Boot application. Okay, how it can be done? By using the simplified setup and configuration. That is nothing but the less configuration and rapid development, because rapid development also required the some set of servers should be ready-madely available, right? So the, the advantage of the Spring Boot is like it is coming along with the embedded servers. For example, we have a Tomcat in place, we have a Jetty in place. Okay, all the embedded servers are part of this Spring Boot Echo world. Okay, so you don't want to separately go and look for the embedded server and put the jar in place. You don't want to bring it. You don't want to run into such a kind of difficulty. We have a Spring Boot inbuilt or embedded server in place where automatically your inbuilt the jar you built by using the code can be put into that place and very rapidly you can bring up your application very shortly. Okay, not only that, it has a lot of features like getting download or auto injecting the dependent jars into your application very quickly. That is the power of the Spring Boot. It is that feature is called auto configuration and dependency injection. For example, if you have a class which have a interdependency with one of the particular class, right? That can be injected based on the dependency transactions. Okay, that is called dependency injection. Okay, and we have a production ready features. For example, as I told you earlier, we have a actuators where you can go and monitor the health check of the particular APIs. Okay, so all the production ready features are available in place in the Spring Boot Echo world. Okay, and also we have a lot of models, other models like Spring Cloud. We have a JPA. We have a messaging progress. We have in the Spring Echo world. We have a lot of more modules are there. Okay, all the models can be supported by the Spring Boot. So tomorrow, if I want to add the Spring Cloud features, right? Or for example, it is nothing but the Netflix Eureka server. If I want to build for the uh, registration for right that kind of time, I can able to easily integrate with the Spring Echo world. Okay, so all the Spring framework features can be easily integrated with the Spring Boot application. That is what it's the power of the Spring Boot. Okay, not only that, it is also supports the cloud native capabilities. Okay, so all the points are very sensitive points and very all because of all these points only developer life got easy and he can able to focus the business problems. Okay, and he can go and connect with the business and done the things very easily. Okay, I'm just undoing the lines actually. Okay, and we have done with this. And coming back to the topic, what is the difference between the Spring and Spring Boot? Okay, the shown things are nothing but the Spring Echo world. Okay, so in the Spring Echo world, we have a lot of items, right? Transaction is there. We have AOP aspects actually. Like that, we have core components also. The core container, which has the bean core context and all there. All the things will be supported by the Spring Boot. Now you have to understand what is Spring and what is Spring Boot. Okay, so in the Spring world, maybe I'm not sure whether you people comfortable with the Spring by now, but I want to give you a clear cut overview, right? Okay, Spring is nothing but by using the Spring also we can able to build the system. Okay, then why Spring Boot? Okay, now you can ask, right? So Spring is like, yeah, if you go and check the Spring application, Spring based application, right? All the configuration, all the setups you have to manually inject. For example, you have here like integration.xml, okay, Spring integration.xml, where you have here class and bean declaration. Okay, for example, I have a login controller, okay, which have a tight dependency of the login service. Okay, during the time you are going to declare your bean in the particular integration.xml class, Spring integration class. Okay, where you will be declaring the bean of the login controller, which have a dependency of the login service IMPL. Okay, so all the things you want to declare by your own and putting into that integration XML. Okay, that is a additional headache for the developer to complete the business problem. Okay, so now in this Spring Boot world, you don't want to do that kind of manual XML based configuration. There is no XML based configuration. You can directly go to your class and then give a auto-wire annotation. Spring Boot will be taking care of it automatically. You don't want to go to the XML creation. We don't have XML in place actually. Okay, we don't have that in such a file called XML where you have to declare the beans. Okay, in Spring Boot, there is no concept like no, that's what I'm putting the word, no XML based configuration. Okay, and it's abstract on top of the Spring Echo world. The Spring Boot is an abstract on top of the Spring Echo world so that Spring Boot can effectively use the all the Spring Echo world modules. As I told you, because of that, it's a developer friendly. Because Spring Boot giving all the features to the developers, right? It is giving the embedded server. It is giving the ecosystem of the Spring Boot, Spring. Okay. And this kind of manual configuration is also overcome. So developer is free and focus about the his coding work. That's the power of the Spring Boot. Okay, so all the difficulty what the developer faced in the Spring based application can be overcome in the Spring Boot world. So that developer can easily focus about his business problem and can able to easily complete the code and promote it to the production very quickly. That's a very rapid to develop, rapid to fast to market. That's very important keyword. Fast to market is a fast to get the money. Okay, so that's about the difference between the Spring and Spring Boot. Okay, hope you guys with me. Till then, please ping in the chat box if you have any doubts. I'm happy to help. Nadim, I'll come back on the other framework. Maybe I can't able to recollect in the other .NET things and all, but they do have their own language to build this Spring Boot application, Nadim. Yeah. Are you people with me till this last slide? Any doubt so far? Because I want to set the base very strong so that you can drive on it very easily. Okay. Thank you, Nadim. And people, we have 5 people already in place. Can you people just give me the things so that I can align with you? If you want to raise the hand, you can ping in the chat box. You can, yes, well, you can do. Any doubts, I'm happy to help you again. Yeah, can you explain Spring Boot in simple terms? Okay, okay, Andrew. I'll explain you very simple. Okay, Spring Boot, right? To build the micro, you know that microservices, right? What is microservices? You have to understand what is microservice. Only then you can understand the Spring Boot. So microservice is nothing but a smallly separated, loosely coupled module. Okay. For example, I told you login module, registration module, and payment module. These are the independent, loosely coupled module. Okay, so that you can easily deploy it and your scalability issue will be resolved. Okay, and then easy maintenance by using the microservices. So basically a microservice is what? You identify the major modules in your single unit, that is monolithic architecture, and breaking down as a single independent microservices that is deployed into the Tomcat services. Tomcat, a web server. Okay. That's about microservices. Why microservices are coming into picture. Okay. To build the microservices very quickly, we are bringing up the popular framework that is called Spring Boot. Why Spring Boot? You can ask. Because of these points only, I am taking that particular framework. What is this? Whatever the developer was facing to build the microservices system, right? That is overcome in the Spring Boot world. In Spring also, we can able to develop the microservices. As I told you, we have to do a lot of manual configuration in your application. That is very hard. It will be ruining the developer's life. He will be maximum spending on his development work on configuring or facing or resolving the issue with the manual configuration. If you go back to any of the Spring developer, he can explain you the pain what they face. To overcome that particular problem only, Spring Boot born, and it will be solving all these problems what the developer is facing in right now. How it is solving? It will be taking care of the setup. It will be taking care of the configuration, and it will be providing you the server to you and auto configure whatever the dependencies you are mentioning in the pom.xml. All the things will be auto configured. In the area, I'll go one step back. In the Spring world, right? You have to identify what is the exact dependency you want to mention in the pom.xml. You have to Maven, visit the Maven repository. You have to identify what exactly you want to accomplish, right? For example, if you want to download any of the Jackson library, right? You have to manually go to the Maven repository, identify the what is the POM dependency. You have to copy it with the version and then putting it to the pom.xml. That can be portable with the other dependent components or may not be not portable. So during the time, it will be giving a lot of headache to the developer to identify the right version of the component. That's really a big challenge. But by using the starter webs, right? The Spring Boot starter kind of package, I'll explain you. But by using that, Spring Boot will be taking care of by its own what is a suitable version for the particular dependency. It will be taking care of its own by using the auto configuration. So this kind of favorism is done by the Spring Boot to the developers. Not only that, it's a cloud native. So tomorrow, if you want to switch from one cloud provider to other cloud provider, it can be just on the fly. We can do it. Now you understand, right? What is the Spring Boot? Yes. Thank Nadeem. How about Andrew? Are you with me, Spring? What is explained in the Spring Boot, Andrew? Are you with me or you want to explain again? Yeah, thank you, Andrew, for that reply. Thank you, appreciate. Okay, so this kind of pain points can be easily overcome in this Spring Boot world. Don't worry, I have a complete hands-on end-to-end. As I told you, as I promised you, 70% will be the hands-on, 30 will be in the slides because you have to understand, right? What is what? Only you can able to connect when I'm coding it. Okay, that's why I'm putting this lot of jargons in this first session. Okay, bear with me. Everything is intentional. Okay, so I'm setting the base slowly. Okay, so now you understand people, right? So what is Spring Boot? What is microservices? What is the advantage of Spring Boot? All the things will be discussed here. Okay, So now we are quite comfortable with this particular session, and I have another 30, oh, more than 30 minutes. Good. Let's break for 2 minutes. Okay, just to refresh yourself in these 2 minutes. I'm going to pause this video and then reconnect in the another 2 minutes. You just get a small refresh. You get a drink, okay, and then get it refreshed. We'll connect back in another 2 minutes, and then I'm going to explain you about the RESTful web services. Okay, let's move on. Get a back on 8:22 in IST, maybe 8:24 or 25. We'll meet up. Okay, just get it refreshed your, because I don't want to put a lot of concept into your very short span of time. I want to give you a break for you guys. That's why I'm giving this 2 minutes of break. Okay, get it refreshed and come back and join again. Let's catch up on 8:25 a.m. IST. Okay, let's catch up. Thank you. Welcome back. Let's start with the session. I'm just sharing the another PPT where we are going to explore more about the web services. Okay. So what is web services? Why we should learn web services? Hope all the people back again, right? Yeah, I can see the participants. Let me maximize it. Give me a second, guys. Yeah. Yes, we can go for it. Okay. So what is web services? These are the agenda. I'm going to set it for the next 30 minutes for you people. Okay, so what is web services? How it internally works? Or what type of web services are there in the market? And what is the difference ultimately? Okay, okay. Why we should understand web services? Now we understand what is microservices, what is the Spring Boot, everything is we are strong on that. At least we know what is what and why we are choosing the framework, because we have not clear about that. Okay, now to communicate between the two microservices entities, there will be a communication to happen, right? So how this is happening? Via web services. It's providing a solid foundation and understanding of fundamental concepts, which will be useful when you learning the Spring Boot. That is the ultimate aim. Why you have to learn the web services. So it will giving a clear picture about the fundamental concepts, right? When you are using the Spring Boot. So when you are communicating between the two independent microservices, this web services playing a major role to communicate to on top of the communication. Okay, that's why one should learn the web services. You have to understand the purpose. Then only you can understand the what is what. That's why I'm setting the clear understanding. Why you have to learn? You have to get the solid foundation and understanding of the fundamental concept how this communication is happening, right? For that, web service is very important. Okay, so we need to understand the common protocol, that is SOAP or REST. The web services is available in so many forms in the market. I am picking very important thing as part of the discussion. That is nothing but the SOAP. Another one is the REST. Okay, that's a kind of common protocol which is used. Okay, so when we were integrating with any of the external systems, right, that time you have to go for the web services. For example, very interesting scenario. Okay, now I have started building one e-commerce application or any of the hotel booking. Okay, well, let's go for a hotel booking. Okay, so I'm building a hotel management website by using the web services. Now the people or the client who is visiting my website for booking my hotel, okay, I want to integrate a small portion where I want to display the weather condition of the desired location. Okay, for example, customer want to go and visit the Kashmir, okay, for the next 5 days of trip. Okay, okay, or Switzerland. Okay, Switzerland. Okay, he want to travel to the Switzerland for the so on so holiday trip for the 5 days. Okay, now in the Switzerland, what is the weather condition for the next 4 to 5 days? I want to display on the time of customer booking. Okay, now for that, that weather condition report or weather conditional detail might be exposed by the third party. Okay, there are a lot of third parties are there which will be providing such data to us. Okay, we need to consume that endpoint and we have to display in the proper style. Okay, in the particular hotel management portal. Okay, that is your goal. Okay, for that you need to consume the provider, the weather detail provider, right? Any, so assume it is XYZ provider. Okay, who will be responsible for providing such a data to us? Okay, he will be exposing the endpoint, okay, REST endpoint or any other SOAP endpoint. We have to consume that via web services only. Okay, so that is the part of why we need to call the web services to integrate the things with the external system. Okay, and then API design and documentation. Okay, so what is API documentation? What is the request payload structure? What is the request structure contains? And what is the response structure? What is the response structure contains? Okay, all the things will be documented in the API design and documentation. So only then you can understand what is the input I need to pass to get the desired output. You have to understand the system, right? What is the provider? What is the provider expecting the input? And what provider will give me the data? For example, the use case, what I have put it in front of you, that is nothing but get the weather forecasting for the next 5 days of the particular location, right? In this case, what is the input is provider is expecting from us? For example, the location of or the city, what do you want to visit, right? And then the date of the visit. So maybe that the two important parameters I can able to think through now. The city you want to visit and what is the date you want to stay in that particular location. This two as an input, if you want to give it to the, the weather forecaster provider system, he will be giving the list of weather, right? What is the humidity, what is the weather, what is that temperature, what is the rain forecasting on the day. All the details will be as part of the response, right? That I need to filter down what parameter I want to display about my decision. So one should understand what is the API design and documentation. Only then you can able to build the system effectively and call these web services, because the provider is expecting the two parameter from you. If you are not failed to provide these two parameter, you will fail to get the response back from the provider, right? So one should understand the API design and documentation in terms of web services. Only then you can start developing the web services. Okay, very simple, right? So for web services, what is the protocol is used? SOAP or REST. Okay, why we require a web services? To integrate with the integration external systems or intercommunication between the two microservices, right? So to building the web services, what is required? You have to understand the API design and documentation to understand what is the request parameter is expected, what is the response layout is expected. Okay, only then you can able to build the effective system in the microservices. Okay, so these are the prerequisites we have to set it, and it is a relevance, right? Industry relevance. All the people in the market, in the industry are following the web services. Okay. So we have to understand about the Spring web services. Only then we can survey in the market. And as usual, once everything is in place, carry an advancement already in place. Okay. So that's what I was about to say. As a client, I am requesting the information from the server, okay, to the particular host. Maybe you assume it is as a weather forecaster server, okay, where I'm posting it by using the internet. All the web services will be happen in the internet, right? Or intranet, anything can be. Okay, so if it is external world, it will be going via internet. Okay, in the internet only, within the internet only, we can able to connect to the desired server and able to get the response back. Okay, so now you understand what is web services, what is the need of it, right? And I'm just repeating and recapping. Okay, so we need to understand the web services because we want to communicate to the one microservice to other microservice, because one microservice you can't accomplish all the goals, right? Right? You have to communicate definitely. Communication is very critical, right? For that only, one should understand the web services. Okay, in web services there are so many protocols are there. So REST and remote RPC, so many are there actually. I don't want to discuss about that. I want to very specific about SOAP and REST. Okay, so that's about web services protocols. And if you want to integrate to the any other external third party systems, then you have to call with web services. And to build the web services, you have to understand what is the provider API design and documentation. Only then you can clear about the what is the request parameters, what is the expected response parameter from the provider. So it is interest and relevance. So one should adapt these web services to meet the expectation in the interview or standard. Okay, and then career advancement. Okay, that's about this slide. Let's move on. What is web services? Okay, it's a standardized way of integrating web-based application using open standard over the internet. So ultimately, it is an internet protocol where if you want to connect between the applications or any of the third party, this is a standard way in the market. Okay, it uses protocols like standard HTTP, SOAP, XML. Okay, all the things are there in the protocol perspective. You can able to choose what is you are going to choose, whether you are going with SOAP or XML or HTTP REST. Everything is up to the developer flexibility. Okay, it's again platform agnostic because SOAP is not a platform dependent or REST is not a platform dependent. That's why I'm calling it as a platform agnostic method of communication. So you can, what is meaning of it? You can able to communicate your Java web-based application to .NET web application by using the web services protocol. That's why I'm telling the word platform agnostic method of communication, because these protocols are not tightly dependent on any of the technology. For example, REST is RESTful web services is built on top of the HTTP protocol. HTTP protocol works in anywhere, right? In internet, it will be work for anything. We have multiple methods. We have get call, we have post call, we have put call, we have delete. So many are there, right? On top of that, we are going to build the RESTful web services. So it is again a platform agnostic, right? So that's the power of the web services. Okay, one can choose what is what. So you can go and choose the REST web services or SOAP web services. It's up to the developer or architect can decide which protocol he want to go with it. Okay, are you clear about this slide? Please let me know. That's why web services W3 definition, what they are giving in that portal, software system designed to support interoperable machine-to-machine interaction over a network. We have to design the system this way by using web services. It's an interoperable machine-to-machine communication over a network. That is called web services. That's a clear W3C definition in their portal. Okay. Going back to the key terminologies, I have to introduce you some set of technical jargons to you people. That is nothing but the key terminologies what we are going to use it. Okay. So request response. What is request? The client who is expecting the response or expecting the output from one of the server, right? He is making a request to the server. That is called request. You people understand, right? Whenever you need some data, you are making a request to the server. That is called request. Whatever the server responds back to the client, that is a response. Simple. For that, there are a lot of message exchange formats are there. The response may be XML. The response may be JSON. The same way, request can be either XML or JSON. I got a ping 1 second. Give me guys. PNR status services. What is that PNR status services? Nadim? I'm not able to get it. Yes, yes. You can go for yes. Ultimately, because the IRCTC is a service which will be providing the endpoint to you to consume to get to know about the PNR status. You will be keying the input as a PNR number. IRCTC will be providing the status of the train ticket with this PNR number and giving you the output. It is also a use of the web services, right? Definitely your system is communicating from one system to other system or a client server based, right? It's a good example, Nadeem. Yeah, yes, you are aligned with me. Yes. Okay, so this particular exchange can be in the form of XML or JSON. If it is XML, it is a SOAP based. If it is JSON, it is a REST based. That's very simple. Okay. And who is the service provider? The client or the server who is providing the data to me as a client, then that is called service provider. The use case, what I have told you, the weather forecaster is the guy who is providing the weather information to me. For me, he is a service provider. I am a service consumer because I'm consuming the data from him. So service provider is providing the data. Service consumer is the consuming the particular data. To make that understanding what is what, the request and response, I have to go and look into the API documentation that is called service definition. The service definition is nothing but the API documentation where you can see what is the expected request from the service consumer, what is the response is coming from the service provider. All the things will be clearly documented. That is called service definition. I'm talking about this particular point. Service definition is nothing but the API documentation where all the request response format and expected field input fields or informations are available in that particular documentation. That is called service documentation. In the SOAP world, we have a WSDL file, WSDL file we have. If you download any of the, I have a slide, I think, okay, where I'll show you. So the file which have consisting of the what is request is expected, what is the response is expected, what is the field is expected as part of the request. For example, in the weather example, I have to pass on the city and the day of the stay, right? Date of the stay. Okay. If I pass it as an input parameter, the provider will be, service provider will be giving the lot of information about the humidity or temperature or rain forecasting. Everything will be provided. That is called the service provider and service definitions. Okay. The transmission protocol can be HTTP or MQ, a messaging queue. Okay. That's called transportation. Okay. So transportation can be either of the two way. One is HTTP or MQ. Okay, messaging queue, any of the queues, brokers, message brokers. Okay, now coming back to the next slide. This is what the particular service definition will be looks like. Okay, so in my service definition documentation, I can have here what is the request and response format, and what is the request structure, and what is the response structure looks like, and what is the endpoint you need to consume. For example, the desire, the service provider have exposed multiple endpoints, not only a weather. He might be exposed that what is air quality. Okay, maybe like that, lot of endpoints he might be exposed. Not only weather, right? He can go and expose the pollution or air quality. A lot of endpoint he may be exposed. All the endpoint declaration will be part of this service definition. Okay, each endpoint, what is the request structure is expected, what is the format is expected, what is the response structure is expected. All the things will be clearly documented in the service definition documentation. Okay, that is the ultimate goal of the service definition documentation. Okay, in the SOAP world it is WSDL. Okay, in the rest world we have WADL, but it is deprecated. We have a swagger in the place where you will be expecting what is the request and what is expected in the response. Okay, all the things will be documented. Don't worry, I have a clear hands-on for each and everything what I'm saying. Okay, don't worry. Okay, you have to consume these technical things. The service definition is a place or document where you will be mentioning all this information. All the endpoints which is the service provider exposing to us or outside, it will be declared here. Each and every endpoint, what is the request and what is the response structure, and what is the format we need to follow. Everything will be part of this service definition. Okay, and what type of web services are there? As I told you earlier, there are several type of web services are there. I am very much keen interested to this two only, first two only. That is nothing but SOAP and REST. What is SOAP? Simple Object Access Protocol. It is XML based. Ultimately XML based. What is REST? Representational State Transfer Protocol. It is a HTTP protocol based. By using this one can achieve the interoperable application property in our web services. Other than that, lot of jargons are there. JSON RPE, remote procedure call, XML repository call. Because I want to you people to understand this, but I am very much keen interested to explore SOAP and REST in the subsequent slides. Okay, you have to understand what existing in the environments or outside. Okay, now we will see the SOAP web services. Okay, so what is SOAP web service? It's a special way of building the web services. Okay, so as I told you, web services can be built in so many ways. One of the way is SOAP web services. Okay, it is a XML based web services. As I told you, the request type and response type will be in the form of XML. Okay, if you download any of the WSDL file, you can see clearly defined what is the request structure is expected and what is the response structure is expected. All will be clearly documented in the service definition documentation. You have to strictly follow that particular thing. Only then you can able to achieve the business problem. This transaction or transportation can happen via MQ or HTTP. As I told you, the service definition in the SOAP world, it is called WSDL, Web Service Definition Language. Okay, any doubts so far? Please ping in the chat box. I'm happy to help you people. Any doubts so far? Please raise your hand or ping in the chat box. Okay, I'm setting up the base, so you have to carefully understand and consume it. Yeah, I got a one more ping. Just me example. Oh, okay. Okay, Nadim, thank you. So this is very clear, right? So why we need a SOAP web services? Okay, what is SOAP? And what are the flavors are there in the SOAP? What is service definition in the world of SOAP is a WSDL. I'll show you one WSDL also, maybe don't worry. Okay, let me go back to the other one. Okay, that's what, same thing. I just taken the same slide only, web service WSDL, how the WSDL looks like. Okay, and then REST web services, as I told you, is a completely based on the HTTP protocol. In HTTP world, we have so many methods are there. That is get, post, put, delete. All are internet based, right? The services allow application to communicate over the internet by using the standard HTTP methods such as get, post, put, and delete methods. Okay. It is a resource based. What is resource based? Resource based is nothing but the place where you want to invoke. For example, if you want to invoke any of the product inventory, the product is a resource. If you want to invoke any of the order management, order is a resource. So it is also always a resource based. REST web service is always a resource based, and HTTP is a stateless protocol, and it can also cacheability and cacheable. Okay. So I'm just repeating the RESTful web services. It is built on top of the HTTP methods. Methods such like get, post, put, and delete is completely a stateless and also cacheable. Whatever the HTTP methods are providing in this, right? All the features will be provided by RESTful web services as well. Okay. Now, there is no clear-cut data exchange format as like SOAP. As I told you, SOAP is strictly following the XML as a request and response structure. But when it comes to RESTful web services, there is no clear-cut format, but JSON is a very much popular in the market. We are also, as part of this course, we will be stick with the JSON. And the transportation perspective for the SOAP, it is supporting the HTTP and also supporting the MQ, right? Message queue broker messages. That is also supported in terms of SOAP world. In terms of RESTful web services, it's only support the HTTP alone. Okay. You have to understand this limitation. Okay. As I told you, the service definition perspective, earlier days, we were using WADL as a service definition for representation, RESTful web services. Now, we are moving away from WADL2, that is deprecated, and we are going to Swagger. Swagger is the place where it's kind of UI interaction where you can see what are all the endpoints are exposed by the provider. All the things will be displayed in this Swagger UI HTML where you can easily test it. It's a kind of interaction based UI. Okay. For example, if you want to get the weather forecasting by entering the city and day of stay, it will be asking you to enter or key in the input in that particular Swagger UI. Once you enter the detail, it will be on the fly, will be providing the data to you, by which you can be able to see what is the expected input for that consuming the endpoint. So that kind of user interaction will be in part of this Swagger UI. So as a developer, you can go and visit any of the provider Swagger UI, where you can see how what are the endpoints are exposed to consume that particular endpoint, what are all the inputs I need to key in, and what is the response structure, everything will be in place. By seeing that, we can start coding it by using our Spring Boot web application and consume that REST response in form of JSON and make the things work. That is the power of the RESTful web services. Okay, you understand now, right? What is REST? Again, I'm coming back. There is no format, but people are using very much popular in the market in terms of JSON format. And transportation format perspective, it only support the HTTP. And service definition perspective, there is no standard, but we were using WADL earlier, which is got deprecated. One at last in the current trend in the market, we are using the Swagger UI, where we will be see the what are the endpoints are exposed by the service provider, how to invoke that RESTful web services endpoint, and what is the input, what is the output. That you can test it in the Swagger UI, and you can start developing based on that. Okay. Now coming to the last topic of the day, that is nothing but the SOAP versus a RESTful web service. What is the differentiation? We already covered. I'm just repeating or recalling it. Restriction perspective. SOAP is a very much strict restricted. Okay, you have must adhere to the service definition documentation that is called digital file, WSDL file, right? You must follow that. You have to stick with the XML base only. You have must stick with the input parameter what is declared in the service definition documentation that is called WSDL file. Only then things will work in the SOAP. But in terms of RESTful, as I told you, there is no clear-cut format, but people are using the JSON. Let's take it up that. It's kind of architectural approach. RESTful web service is nothing but more than the restriction. It is kind of architectural approach. So it is built on top of the HTTP methods to meet the interoperability across the systems. And it has providing the service definition in terms of Swagger, as I told you. By using that, you can start building that. I'm just repeating the same point again. In the point 2 data exchange format, it is following the SOAP XML based data exchange in the SOAP world. In the rest, we are using very much popular one, JSON. Service definition perspective, in the SOAP world, it is WSDL. In the rest world, there is no clear-cut documentation. We were using the Swagger UI to get to know about what is what in the request and response. And transportation perspective in the SOAP world, it is supporting HTTP as well as MQ, that's message queue or message broker like Kafka or something like that. In the transportation perspective for the RESTful web services world, it is only support the HTTP. So you have to understand what is SOAP, what is RESTful, how to build the web services, right? One should understand the web services only. You can go to the Spring Boot and you can start coding it. That's a base, right? Because because in the Spring Boot world, Spring Web Services world, you have to communicate one system to other system. The communication plays a critical role to get the data done, right? For how the communication is happening via web services. There are two type of classification as part of the web services. One is SOAP, another one is REST. Okay, based on the your need, you can choose free to choose any of the thing. In as part of this particular course, we are going to choose the RESTful web services and data format is JSON. Okay, through which we can able to communicate to one microservice to other microservices or one microservice, third party microservices or third party systems by using the RESTful web services. So one should understand the web services, only then he can go back and start develop for the communication perspective. Spring Boot to microservices to another microservices. That's why I said the base about the web services today. Hope you guys understand till this last slide. Any doubt so far, any of the slide, please free to open up. Okay, in the chat box. I am free and happy to help you. Okay, all the data, whatever things we have seen. Any doubts so far? I'm looking for the chat box. Anything's popping up? Any doubts? Thank you, Nadeem. Other people, other audience, please happy to help me to shoot up the question. Any doubts? Any, it will be small. Any doubts? Silly, no problem. I'm happy to help you people. Just ping me in the chat box. We have another 3 minutes. We can effectively utilize it. Okay, I understand this as a strong message from you people. Okay, Andy, how this communication secured? Yes, Andrew, actually, for that only we have a separate module in place that is called Spring Boot Security. When I'm integrating that Spring Boot security on top of my application, I will make sure that my endpoints or my application is secure. I have a separate hands-on and discussion topic very specifically about the Spring Boot security, where I am going to cover as much as in that particular session by using the Okta. Okta is a authorization server which will be authorizing the web services by using the OAuth 2 protocol. OAuth 2 is one of the authorization way where you can, it's a kind of token based actually. Okay. So it's a kind of token based. It will be by using the OAuth 2, you can able to validate whether it is the valid client or valid request. Then you can make the application secured. Don't worry, I have a separate. What is Kafka? I heard you have mentioned. Yes, Kafka is nothing but the message broker. You know what is message broker, right? Message broker is nothing but the place whenever you want to do the system asynchronous mode. You know asynchronous mode, right? So you don't want to really wait for your response once you place a request. So for example, very simple use case, whenever you are ordering any of the order in any of the e-commerce systems, for example, Amazon, I'm logging into the Amazon. I'm just going to order any of the product. Okay. So now placing an order is a real-time call. Okay. For example, I'm doing the order and then following by the payment. So if this is a synchronous mode, because synchronous nothing but I'm waiting for my request to come back with a response. Okay. I'm waiting for my response should be come back for my request. Okay. That is called synchronous mode. Okay. For example, order placement and payment for the order payment, right? All are synchronous mode. For example, if I want to do send out any email notification after the order placement, it's not really to be a synchronous mode, right? It can be come after my order placement also fine, no problem. After 10 minutes, after 15 minutes, my notification about my order placement coming to my inbox or email, it's quite okay with me. That's not such a urgency. That is called asynchronous mode. To build the asynchronous mode kind of communication effectively, you have to rely on the message brokers. Okay, the message broker is the place where the provider will be putting the message on the message broker. There will be a message listeners will be there in other end who will be consuming the message and then do the need. As like given an example, email notification after the order placement. Okay. The email notification listener will be listening the Kafka or any of the message broker where it will be consuming the particular message and then send back the email notification to the respective customer. Okay, this is called asynchronous mode. To accomplish the asynchronous mode of communication, you need a message broker. The effective market broker right now is Kafka and Solace. Okay, that's about the answer, Andrew. Okay, and what will be the I need to practice on the for this session? What today 2 hours we gone, right? You just to revise the thing. You have to understand what is microservices. You just recollect what I have uh, teach you, right? You just understand what is what, so that uh, tomorrow or next week when we connect, right? When we are doing the hands-on, I can able to connect the all the concepts what I have teach you in this session. Okay, so don't worry. Practice session, I will be taking care of it. You just follow me. You will be feel comfortable day by day. Okay. Sorry, I got another ping, Rajesh. Yeah, using SOAP and REST able to communicate with the different language application. Yep, that's true. Web service is nothing but, that's what I was repeating the word, interoperability application. Okay. So what is what? That is the one thing can communicate two different independent language agnostic application by using the web services, because web services using what? It is using the SOAP, which is the again the interoperability, right? It is not a language agnostics actually. Okay, there are HTTP method, HTTP methods, and SOAP is it's not tight bound with the any of the technology stack. That's why SOAP and RESTful are communicate with able to two different web applications without any flaws. You got it, Rajesh? Now, practical demo. I think yes. I need to do pre-setup actually. To for example, I need to do you people to because I'm going to teach everything in the latest technology only. Nadeem. Okay. For example, Spring Boot 3, which is actively in the market, so that I can promise you people to connect to any of the interview on the fly. I can crack it. That's my agenda actually. That's why I am taking the latest Java 17 and latest Spring Boot 3, and that's the latest stack I'm picking to make you people to meet the current market trend. That's my agenda. Okay, so I'm going to teach everything in the latest technology only, Spring Boot 3, just remember, and Java 17. Okay, yes, pre-request it. Yes, I need it. You just start installing the Java 17 and Spring and IntelliJ IDE. That's a prerequisite. Yes. Okay. Just download Java 17 in your local host or local machine, and then IntelliJ developer community also. It's fine, no problem. Okay, you just download the freely available community edition. Just get it done so that we tomorrow let's go back and refresh the small induction. Okay. Any doubts, guys? Are you clear about the concept today? Shall I use Ubuntu OS? Yeah, fine, no problem. It's up to you, Rajesh. No problem. But as part of the demo, what I'm going to do, everything will be the window based only. Okay. Thank you, Rajesh. Thanks for your reply. Any doubts? We are overrunning by 4 minutes. Don't problem. I want to clear all the doubts then and there. That's very much important for me. I'll make sure all the concepts are clear. Only then I will leave you. Just for joke. Okay. I'm happy to help you people. Let's catch up tomorrow. We have a lot of fun tomorrow. Okay. Happy learning again. Stay connected. Thank you so much for joining this demo class. I'm happy to help you. Thank you all. Happy learning.